Alright, today we will be factoring out the greatest common factor in a polynomial. So what it is, it's basically like the reverse distributive property, like to where if you had 3x plus 2 as a quantity times 3 and you distribute that through, you'd have 3x plus 6. Well, now you can see that there is a multiple of 3 in each one of these terms, so we are going to do the opposite of we're going to undistribute. So we're going to find the biggest number that goes into both of these terms, like the greatest common factor. And you can see that 7 definitely goes into 7, and 7 goes into 49, so that means that I could factor out a 7. So we're going to put that on the outside of the parentheses. But you also got to check your variables to see if there's like the same amount of variables in each. This term right here has an x with it. This does not have an x with it, so you cannot factor out any kind of x's in this situation. So 7 is the greatest common factor. And then what goes in the parentheses is you just kind of divide how many times does 7 go into 7? One time. And then there's an x with it. And then the plus is still there, and 49 divided by 7 is 7. So if you were to distribute this through the parentheses, then you would get 7x plus 49. So, and you really don't need to put the 1 in front of the x, but I'm just kind of showing you how it works. So we have factored out the greatest common factor. Let's do that again on number 2 here. Let's find the greatest common factor just between the numbers here, between 8 and 6. 2 will go into both of them for sure, but is there anything larger? Will 4 go into both of these? No, and that's it. So 2 is the greatest common factor number-wise. Now variable-wise, this has an m with it, that does not have an m with it, so we cannot factor out any variables. So now we'll do a little bit of division. 8 divided by 2 is 4, and m had no one to play with. That is a minus still, and 6 divided by 2 is 3. We are factoring out the greatest common factor. So very, very cool trick right here. Now let's go with numbers. Again, here on number 3, you can see that 5 will go into each one of these numbers. And when it comes to variables, this has some a's with it, but that doesn't have any a's with it whatsoever. So the greatest common factor between 5a squared and 15 is 5. Then we do some dividing. 5 goes into 5 once, and there was some a squareds with it. There's a minus right there. And then 15 divided by 5 is 3. You can always check by distributing again and seeing if you get back what you originally started with. So on number 4, you got a 10 and a 25 for numbers. 5 is the greatest common factor that goes into both of those. But you notice that each one of these terms has a q in it, right? This has a q to the first power. This has a q to the second power. You always pull out your smallest amount of q's, right? The smallest amount of q's. And that's q to the first power. So now let's do some dividing. 10 goes into 5 twice, and q divided by q cancels each other out. Q divided by q is 1. Then minus 25 divided by 5 is 5, and q squared divided by q, right? Don't you play the where are there more game, and aren't there more q's upstairs? So you got q to the first power. So you end up just subtracting the exponents. 2 minus 1 is 1. And if you check, you got to look inside the parentheses to see if that is prime, meaning the GCF between them is 1. You can look at it at all of ours. Numbers-wise, between 2 and 5, the only thing that goes into them evenly is 1. This has a q in it. That does not have a q in it. You can see up here, 7 and 1. 1 is the biggest number that goes into both of them evenly. This has an x. That doesn't have an x. Between 4 and 3, 1 is the largest number. That has an m. That doesn't have an m. And that's the way it works. When you truly factor out the greatest common factor, what's left inside the parentheses is prime, meaning the only thing that goes into all the terms evenly is 1. So let's do that with number 5 here. Remember, you want to find the greatest common factor between these numbers. It's true that 2 goes into all of these numbers, and 4 goes into these numbers, but 8 goes into each one of these numbers evenly. 8 goes into 8 one time, 8 goes into 56 7 times. But notice also, variable-wise, each one of these dudes has an a in them. So we can factor out an a, and it's the smaller amount. In this case, it's a to the first power. Now this has an x with it, and that does not have an x with it, so x cannot get factored out. X is not a factor in every term. So we will now divide. A divided by 8 is 1. A divided by a is 1, and there's an x left over. minus comes down. 56 goes into 8 7 times, and a divided by a is 1, so it doesn't really go in the parentheses. And you can see the green thing is prime. The only thing that goes into each one of these is 1, because the coefficient of this is 1 right here, and that's prime there. So now let's try number 6, and they start giving us some large numbers, so that's hard to deal with. Pick your bigger guy, right? Start writing out multiples of the bigger guy. Isn't 1 times 81 turn out to be 81? And neither one of these numbers goes into 48 evenly. 2 doesn't go into 81, but 3 goes into 81 27 times. And 9 goes into 81 9 times. These are all your factors of 81 right here. Well, are any of these numbers a factor of 48? Well, 9 is not a factor of 48. 81 is bigger than it. 27 doesn't go in there, and you know 1 does, but is 3 a factor of 48? 3 sure is, so we can factor out a 3 when it comes to these numbers. Now, when it comes to the variables, each one of these has an r with it, so we take out the smaller amount, and they're both the same. It's r to the first power. And this guy has a t, and that has no t, so we cannot factor out any t's. Now, divide. 81 divided by 3 is 27, and r divided by r cancels each other out. 48 goes into 3 goes into 48 16 times. R's cancel, and there's a t left over. And you can see that what's inside the parentheses is prime. So we have factored out the GCF, the greatest common factor. Numbers-wise, well, there's a 1 here and a 3 there, so there is no number that we can factor. I mean, you factor out a 1. I mean, you really don't do that. So you got to go variable-wise. This has got some t's in it. That's got some t's in it. So you factor out the smallest amount of t's, which is t to the first power. This has some h's. That does not have some h's, so we cannot factor out any h's. And now it's time to divide. T squared divided by t, you just subtract these exponents, and you'll have a t to the first power still. And there will be an h with it also. Then the plus comes down. There's a 3 involved, and the t and divided by t cancel each other out, to where you're left with this. We have factored out the t. Let's try number 8 here. Coefficients are all 1, so we got to factor out some variables. There's some a's in each term. Remember, the terms are separated by addition and subtraction signs, so I kind of left that out, but you can tell just by separating from the addition and subtraction that there's an a to the first in each guy, and that's about it. So we'll divide, and the b squared comes down, plus a divided by a. You know, we always say they cancel each other out, but there's nothing left over in that term, so a divided by a, you got to put the 1 right there, right? You just can't leave that blank, right? A divided by a turns out to be 1. Just like 5 divided by 5 is 1, and a million divided by a million is 1. So realize that this term cannot just disintegrate. There's still something there. Here we got a 3-termer, right? We got 1 term here, if my pen would work, and second term, and a third term. You have to take out the common factor in every single term. So it comes to the coefficients, they're all 1, but doesn't every term have some sort of x in them? You take out the smallest one you see, so that's x to the first. Now this has some y's in it, and that has some y's in it, but this term does not have any y's in it, so you cannot factor out any y's. It has to be in all the terms. So, time to factor out and divide. So x divided by x is 1, plus x squared divided by x is x to the first, and this y comes along for the ride. And x cubed divided by x, you subtract the exponents, and you get x squared, and then the y squared has no 1 to play with either. And you can look inside here. This is prime. It has to be all 3 terms. What's the greatest common factor? Sure, this has an x and a y in it, that has an x and a y in it, but this doesn't have any x's or any y's in it, so that is prime inside the parentheses. Let's try number 10 here. This is a 3, this is a 6, and this is a 1 for a coefficient. So even though you have some factors in these 2 terms, it's got to be every term. So the greatest common factor number-wise is a 1. This has a p, this has a p, this has a p, and what's the smallest amount of p's is p to the first power. This has an r, this has an r, this has no r, so all we can factor out is the p. Then we do our dividing. This number has no 1 to play with. P squared divided by p is p to the first. You subtract your exponents, and r squared comes on down also. Plus 6, the p's cancel there, right? And you still have an r. Plus p divided by p is 1. So, number 11 here. All three terms, coefficient-wise, a 4, a 16, and a 12. 4 goes into all three of those, so we can take out a factor of 4. Then this has an A, this has an A, and that has an A, so we can definitely take out the smallest amount of A's, which is A to the first power. And this has a B, this has a B, this has no B's, so we are done factoring out. Now it's time to divide. 4 divided by 4 is 1. A squared divided by A is A to the first power. B squared comes down. It had no one to divide with. Plus 16 divided by 4 is 4. A divided by A is 1. And B has no one to play with. 12 divided by 4 is 3. A divided by A is 1. So 3 times 1, which is 3. And inside of there, this is prime. Has B's, has no B's. Has A's, has no A's, has no A's. So that's prime. Why don't you try number 12 on your own? Give the video a pause and see if you can factor out the GCF. Numbers-wise, all of these are even, so 2 is the common factor in that. And then H-wise, they all have an H in them, and the smallest one is H to the first power. And N-wise, they all have an N in them also, so we can factor out an N. And the smallest one was N to the first power. So 5H squared N to the second, because you subtract the exponents. Minus is the sign. 2 divided by 2 is 1. H divided by H is 1. N squared divided by N is N. And then plus 7. H divided by H is 1. N divided by N is 1. So there we go. That there is GCF, greatest common factor. We'll use that often in an algebra course, especially in Advanced Algebra 2. The zero product property is pretty simple. If you have two things times each other, they're saying you got A times B equals 0. Then here's the fact, Jack. At least one of those dudes, A or B, or even both of them, must be 0. Like when two things multiply together to be 0, at least one of those things has to be 0. Like 5 times 0 equals 0, right? One of those things had to be 0. So when you have an equation that is equal to 0 and it's in nice, neat, factored form like we were just doing, it's very, very simple because you have two terms basically. You have this green term and you have this red term, right? There's the two terms because, yeah, sure, there's some junk inside the parentheses, but the grouping symbol says look at it as a group. You got green thing times red thing equaling 0. Well, we need to figure out what the two things would be that would make this 0. So, if the green thing was 0, this would be true, and that's pretty simple because that would just mean that x would equal 0. Let me make that green. That's what I was trying to do. If x was 0 right here in green, that would be a true statement. The other thing is if this red thing was 0. So you could go off to the side and say, well, x minus 8 has to be 0. And just solve this for x and say x equals 8 by adding 8 to both sides. So you got two answers in this situation. X could equal 0 or x could equal 8. There are two possibilities that would make this a true statement. And then what they like to do is they like to put that in set notation. Like what is the set of answers in this? So x is 0, x is 8. You put the fancy schmancy set brackets like this and you write your two answers inside of there separated by commas. 0, 8. So again, here on number 20, you've got two terms times each other equaling 0. The green thing could equal 0, and the red thing could equal 0. So what would make the green thing 0? Well, if B was 0, that'd be quite simple. And here, what would make the red thing 0? Again, the whole concept here is you're saying, well, B plus 12 should equal 0, right? I want to know what would make this 0. Well, you subtract 12 over and B equals negative 12. And can you see it's just the opposite of this number, right? If this is 12, this number has to be negative 12 for that to turn out to be 0 when you add them together. So B equals 0 or negative 12, right? And then you write that in set notation. The set of answers is 0, negative 12 with those fancy brackets. I know those brackets are hard to make. You know, just do your best to try to make the bracket. It's not a parenthesis. This is not an ordered pair. This is a set. So here now we have two groups of parentheses times each other. You got a green one and a red one. We want to know when at least one of these will be 0 because of the zero product property. If at least one of these was 0, then this will multiply out to be 0. So what would make the green thing 0? Well, wouldn't, if m was 3, wouldn't that work out? Because then you'd have 3 minus 3, which is 0. It's just the opposite of that number. Or the red thing, if m was negative 5, that would work out too. So there's our solution set, 3, negative 5. That's what this is called. What we're doing right here is the solution set. Like, what are the solutions to this situation? And here we go again. What would make this group of parentheses 0 is if a equaled 9. Or what would make this one equal 0? Well, you could go off to the side and solve your equation now, because notice the coefficient of a is not a 1 like it was real easy. So you have to say 2a plus 1 equals 0 is what we're looking at. First move is to subtract 1. So you have 2a equals negative 1. Then divide by 2, and a equals negative 1/2. So if you're not sure, you can just take that expression and put it over here equal to 0, and there's your solution set of 9, negative 1/2. Not parentheses, but brackets, Mr. P. These next guys, ooh, they don't have it in the cool parenthesis format, you know, where it was in nice, neat factored form. So if we could factor these, it would be much easier to solve. This is kind of what Algebra 2 is all about, is if you could factor these, it would be good news for us. So you notice that each one of these, numbers-wise, is greatest common factor is 1, but each one of these has an x in them, so I could factor out an x into each one of these, and now do my cool little dividing trick. X squared divided by x is x, minus comes down, 5 had no one to play with, and x divided by x cancel each other out, and bring down the equals 0, right? You got to keep it an equation. You can't just kind of factor it and then get your answers. It's got to stay an equation. You can only solve an equation. So now I could solve this equation with the zero product property. If x was 0, this would be a true statement, or if x was 5, this would be a true statement. Now, too many people, like I said, they factor this, but they don't keep the equal 0, and then they all of a sudden have an answer. It's got to be an equation before you can have an answer. So keep the equal 0. And then our solution set is 0, 5. Those are the only solutions to this situation. So let's do that here on 24. It's not in factored form, so if we could factor it, that'd be great. We could factor out a y in each one of these terms. So y squared divided by y is y plus 3, and then y divided by y cancel is 1. And that still equals 0. And now we can use the zero product property to say y equals 0 or negative 3. And my solution set is 0, negative 3. Get used to this solution set. They do it a lot in Advanced Algebra 2. They do it a lot in College Algebra. Here, this is not even equal to 0. So first we can get it equal to 0 by subtracting 6a, like taking that 6a to the other side. So wouldn't I get 3a squared minus 6a equals 0, right? All I did was move that over there, and now there's nothing left on the right side of the equal sign. And now this over here can be factored. A 3 goes into each one of those, and an a goes into each one of those. And what's left is a minus 2 equals 0. And then what would make this turn out to be 0? Remember, it's 3 times a equals 0 is what you got here. Divide both sides by 3, and a still equals 0, right? So a could equal 0, or a equals 2. That would make this guy turn out to be 0. Solution set, 0, 2. And then finally, let's do that to this one. It is not even equal to 0, so let's get it equal to 0 by subtracting 3x from both sides. So 2x squared minus 3x equals 0. Now that this is equal to 0, this is factorable over here because there's an x that goes into every term. So we'll have a 2x minus 3 in there. And now we can do the zero product property. X could equal 0, or if we go off to the side, you get 2x minus 3 equals 0. Add 3 to both sides and get 2x equals 3. Then divide, and x equals 3 halves. And our solution set is 0, 3 halves. So that there, my friends, was factoring out the GCF, and then we used the GCF to help us solve some basic quadratic equations. That's what this is called when you've got stuff to the second power. Homework is the backside of this worksheet. Let me know if you have any questions, and have a good one.